Hello everyone. So this is the last concept in the MapReduce environment. The NoSQL concepts in Unit 3. So already most of this concept is covered in the Unit 4. Actually, there is the overlap here, the content. So as an overview, I'm giving this content. Okay. So the MapReduce. Let us go with the MapReduce. As you know that. Uh, the MapReduce, it is the concept of dividing the data into different chunks and they will be processed on different machines and they will be executed on top of the distributed environment. So that is a MapReduce. Uh, Basically, the MapReduce is introduced in the Google and it was adopted in the Hadoop environment. So the Hadoop is also completely based on the MapReduce concepts initially. Okay, so distributed environment. And so we can go with that. Centralized versus cluster-based systems. As you know, the centralized system, meaning that it may fail, or if it fails the process, then we will lose the entire thing. Again, we have to start from the beginning, and we may lose the data also. That is the centralized databases and cluster-based system. There will be the replication factor and fault tolerance is also available. All these are available in this in the distributed environment. The distributed systems, they will have the fault tolerance concept and all the environment to handle the failures. Okay, so that is called the MapReduce environment. And then understanding of the map reduce, it divides the data, it divides the complete computation process into map and reduce two parts. The map will filter the data. Most probably, it will be filtering the data. So in most of the cases, and the reduce, it will combine the filtered data into a common place, and that will aggregate the result so that we will get the final result. So everything is completely based on the key value pairs. Here the key component is the key value pair. And here there will be the map function and there will be the reduce function. These two are available. And how the map reduce works is parallelism in the map, that is the parallelism in the app, data locality. These are the various points. Already you know about very well about the map radius because of the fourth unit. And so the map function, we can define the map function as the business logic and the reducer, that is depending upon map function, and map phase, that is depending upon the size of the data and also how many chunks it is divided. That is, the chunks means the how many splits are divided. Those many number of mappers are required. Those many map functions are required. And that map function, it will handle, each map function will handle a single record, and it will perform some operation on that record, and it will produce the output. And the important thing is the input and output of the map is also the key value pair. And reduce function, it will collect all the outputs of the map function, and it will collect key wise, meaning that for every key, for every key, there will be a separate reducer, so that reduce method. So each key will be the each key related data will be separated, and that will be given to one reduce function, so that it will work on that and aggregated in the reduce function, and the result will be given. So that is a reduce function. And how the map reduce will work, the detailed workflow of the map reduce, it was given in the in the fourth unit, but here we are just giving the overview. In this parallelism in the map, all the map functions, see, the data will be divided into several chunks. Let us say, for example, if we have the 500 MB data. The 500 MB data will be divided into several chunks. It may be with the 64 MB. So 64, 64, 64, 64, like that. For number of 64 MB chunks will be available. all those chunks. For each chunk, the mapper will be allotted, and that will be executed. The mapper will execute on the given particular chunk, and it will execute. And number of mappers will be created for the number of chunks or splits. Okay, so all these splits will be executed in parallel by the number of map functions, and that is the parallelism in the map, so that the process will be speed up automatically, and it will increase the performance of the execution. And data locality, this is very interesting. And where the data is available, actually the data is available in the HDFS on background. So in the HDFS, the data is available, that is in the physical blocks, and the map reduce will have the logical blocks. Okay, and most probably where the data is available in the physical blocks, the logical block will be also set on the at the same location, so that the map function will be allotted at that location. At that location only it will be executed, so that the local data can be accessed very easily and computed. So data locality is also very important in this case. So now, where the data is available, there the process will be executed in most of the cases. But of course, in some situations, it may not be possible. The function may be available somewhere, and the data may be available somewhere. It has to transfer the data, or at least something, some part of the data has to be transferred. So the minimum transfer is possible in this case. So all these are the areas. This complete workflow of the map reduce that was explained in the fourth unit, you can refer that. The same questions will be repeated here also. Okay, so we can go with the next level. We can go with that. Yeah. And here, partitioning and combining. What is the partitioning and what is the combining? See, if you give, this is also clearly explained in the fourth unit, but still, let us have a look on this. So, uh, the map method, it will execute on a split based on the different key value pairs. Again, it will produce the key value pairs. In those key value pairs, in those key value pairs, the same key, the key value pairs which are having the same key, they have to be separated into a separate unit. And let us say, for example, key 1, 2, 3 are available. Key 1 related data, key 1 related values, all of they have to be partitioned into separate location in one unit. Key 2 related data will be in another unit. Key 3 data will be available in another unit. So like that, the data will be the entire outputs of the mappers, they will be separated and partitioned based on the keys, so that the each partition, that partition will be given to the, actually they are called the regions here. Those regions will be given to the corresponding reducers. Okay, so that is called the partitioning concept. Okay, so here the partitioning, let us say, for example, here you can see that partitioning example, the if the map function emits, see here 123, if the product ID is 123, in that if the function emits the pace, let us say, for example, product ID 123, quantity is 2, product ID is 123, quantity is 5, 124, quantity is 3. Now, in this case, the partitions, two partitions will be created. Partition 1 is the 123 product ID, and 124 product ID, it will create another partition. So, meaning that what are the values? What about these values? The 2 and 5 will be in this partition, okay, and 3 will be in the second partition. So these are the this is the example of the partitioning of the output of mapper. So once if it is partitioned, then it can be combined. We have to combine that. So the combiner function, what the combiner function will do is, the combiner, it will take the data from the outputs of the mappers, and they have to be combined, meaning that let us say, for example, there are 5 mappers available. In every five, in every mapper, there may be the data for key 1. Let us say, for example, key 1 related data, it is available in the mapper 1 output, mapper 2 output, mapper 3 output, and mapper 4 output, and also mapper 5 output. So what the reducer will do is the reducer has to take the corresponding data from all the mappers, the key one, and it has to be combined, and then it has to process something. And key to related also, it is available in different places. All of them they have to combine into the reducer side. So let us say here the combiner example, the map function emits the multiple pairs. I see here product ID 123, the quantity is 2, and product ID 123 quantity is 5, and the combiner it will it could sum the we have to sum this actually for the product ID one. This is from one mapper and this is from another mapper. Now I want to get the total quantity for the product number 123. So for that I have to combine these product IDs based on this key, and we have to add this 2 and 5 so that 7 that will be available in the reducer that will be generated. So this is the combiner reducer concept. So combiner concept, it is on the reducer side. So the partitioning and the combining, these two are playing the important role in the map reduce method. And of course, with the diagram we have explained in the unit 4 in detail, we can go through with that. Okay, and now we have given one example also, calculating composing map reduce calculation. How we can calculate the aggregates? For that, we have a simple example here. Aggregate calculation example. Map outputs. Here we can see that product ID 123, sum is 200, and the count is 5. Actually, the map will give you the sum only, and the count, the sum, meaning that how many number of entries of product 1 is there, that is the mapper will produce, and count how many number of times this product is ordered, that is another thing. Now what the reducer has to do is the reducer has to take this 123 product ID. For that, the reducer has to take the sum and also this count, and it has to perform the 200 by 5 so that it will give you the average is 40. So the reducer, it combines the sum and the counts across the different mappers and calculates the final average. The final average will be calculated by the average by the reducer. So this is the concept of the composing the map reduce method, and it is the partitioning and combining. So this is about the concept of the no SQL concepts in the third unit discussed. Okay, so most of that it is having several things, and the detailed material was provided in the examination point of view. In this unit, we are not having that much of stuff actually. So it is not the practical oriented; it is just the theory oriented. Whatever is required that I have given the as the summary in these videos. So you can go through the material and please follow the textbook for any concept. Please follow the textbook. This is very important. So I have given the mapping between the syllabus and the textbook chapters also I have given clearly. So please go through it, and you can execute all of them, and you can prepare well for the examination. I hope you understand all these concepts, and I hope I have given the sufficient stuff for this subject. Thank you.